Okay, hello, and it's exactly 4 p.m. Finnish time, so we will start the webinar today. I am Eetu Helminen, will be your host today, and moderating both the panel discussion later on and moderating in all the other participants. So welcome to Helsinki Energy Challenge webinar. The city of Helsinki has launched a very ambitious €1 million challenge competition to find an answer to a question: how to decarbonize the heating of Helsinki using as little biomass as possible. This particular webinar is mostly about encourage innovators to join the challenge and also simultaneously form teams to make high impact winning proposals for the Helsinki Energy Challenge. And for that, we will have a good program today. We will start with welcome note from the Mayor of Helsinki, Vapaavuori, then Uuttu-Deschryvere, a project director of City of Helsinki, and Kaisa-Reetta Koskinen will explain what the challenge is all about and why is it being organized. And then we will have a panel discussion with three really good experts. Marcius Extavour from XPRICE Jukka Leskelä from Finnish Energy, and Vesa Silfver from Motiva. And then on top of that, 5 pitching ideas, 5 different innovators and challenge solvers that will pitch their ideas and look for new team members to make sure that their application will be as strong as possible. But first, I would like to welcome our distinguished guest, Jan Vapaavuori, Mayor of Helsinki. And Vapaavuori is going to give you a few words to begin with.
Thank you, Eetu. Good morning, good day, good afternoon, good night, wherever you happen to be. It's afternoon, a very sunny, nice day in Helsinki, just at the time being. Let me shortly explain what we are doing, why we are doing that, and how we are doing it. The City of Helsinki is strongly committed to become carbon neutral by 2035. We do have a relatively good track record. So far, we have already been able to reduce the emissions by 28% since 1990. Actually, the figure is even more impressive when you calculate it per capita, because the city has grown all the time. So actually, we have been able to reduce the emissions by 45% per capita since 1990. But there's still a long way to go, and you could even say that we have been able to pick the low-hanging fruits so far, and now the task is becoming more and more demanding. As we all know, it differs a little bit around the world what is the main challenge. For us, it is heating the city, due to several reasons, mostly of course due to the fact that we have a relatively cold climate here in Finland. So today, more than 50% of all emissions in Helsinki relate to the heating of the city. And there, when you then go to the heating system, say that more than 50% of the problem is due to the fact that we still use quite a lot of coal in the heating system. So the conclusion is that in order to really make a progress towards a carbon neutral city, we need to get rid of coal, and we need to get rid of coal in our heating system. And that is the main question. We do have 2 big coal-driven power plants in the city of Helsinki. We have already decided to shut down the first one by 2024, and we have a plan how to do that. Then the next stage will take place in 2029, and now we don't have a plan how to make that. You could say that there is a relatively easy, simple way to replace coal in the heating system by replacing it by biomass. But even if Finland, even because Finland is one of the promised countries of forestry in the world, we do not believe that burning biomass for heating a city would be a sustainable, truly sustainable way of doing that in the long run. And that's why we are now seeking for new innovations, how to replace coal in our heating system. And because we don't have the plan, we don't know how to do it, we decided to invite the rest of the world to help us in order to find the best, most modern, most innovative way of replacing coal in our heating system. Of course, we're doing it in order to ask the rest of the world to help us in order to solve our problem, in order to solve the problem how to heat Helsinki in a truly sustainable way in the future. But by doing it through a global €1 million energy challenge, we strongly believe that we will get a great number of different kind of innovations where maybe only some of them are actually relevant for us. And of course, if they're relevant for us, they may be relevant for some other cities as well in the world. But we think that we also will get a big amount of good ideas which actually are relevant, if not for us, for some other cities in the world. How to change the way we are heating cities is, of course, not a Helsinki specific issue. It is an issue and challenge for a huge amount of cities all around the world. We hope, we think that through this kind of competition, we will get some ideas which will bring both Helsinki and hopefully several other cities all around the world closer to a decarbonized city and decarbonized world. That is the story in a nutshell. I'm glad and proud that you are interested in this challenge we have launched, and I hand over to my people who explain it in more detail what's all about concerning the competition. Thank you very much. Good to have you here with us.
Thank you very much, Mayor Vapaavuori. It's very interesting to hear where Helsinki City is coming from. And next, we will have Laura Uuttu-Deschryvere and also Kaisa-Reetta Koskinen to explain what the challenge is all about and where Helsinki City is also coming from. So I will have to give the hosting rights to Laura so she can share her presentation.
Thank you, Eetu, and thank you everybody for joining us today. I'm very, very pleased to walk you through the Helsinki Energy Challenge. What is it all about? And to really convince you that in case you didn't submit your application, you really should in order to make a difference and in order to tackle this challenge together with us. I will walk you through a little bit of the background, but mostly I will walk you through the process and the evaluation criteria. So how on earth are we going to evaluate all the interesting proposal that we are going to get? After my presentation, my colleague Kaisa-Reetta will walk you through the current heating system to give you a little bit of information on that, and more information is available on the challenge website. I know some of you have been perhaps hearing me several times this spring. We might have even met in the opening event, so the content is more or less the same as we have many newcomers today. So please feel free to do something else if you're hearing my story already 10th time, but I'm happy if you still want to hear me 11th time. All right, let's check if I am mastering the slides. Eetu or somebody at the technical side, I seem to be not able to.
You should be the host, so you should be able to share the.
Is it perhaps because it's not on the presentation mode? Should you change it to, or is it in the presentation mode?
You should just share your slides, I think.
There's a button at the top of the screen that says play. That might be presentation mode.
Yeah.
I can't change. Perhaps Eetu, you can change from on my behalf.
I'm happy to.
Yeah, you can take the next one. Thank you. Yeah, well, as our mayor just briefly presented you, the city of Helsinki wants to be carbon neutral by 2035. We have a massive plan on how to reach that goal. We have several actions that go across the city function in order to get to our carbon neutral 2035 plan. But as you heard, the low-hanging fruits have been used and are being used, and we are doing a lot in every sector within the city. But the real problem is the heating of the current heating system. More than half of the emissions are originating from heating the city. Eetu, you can take the next slide. We have you could say that the city of Helsinki thought that we have time until 2035 if we follow our own plan. But a while back, the Finnish government decided to ban the energy use of coal by May 2029, which is a kind of a positive enforcement that pushes us to move faster. So not only we want to get rid of coal, but on top of that, we are forced to do so by 2029. And if you consider that still more than half of our heat is produced with using coal, we have a massive challenge in our hands. So through this challenge competition, we aim to find solutions that help us to answer the question, how can we decarbonize the heating of Helsinki using as little biomass as possible? Eetu, the next slide, please. As you heard from our mayor's opening speech, we really believe that bringing people together, people with different backgrounds, we managed to create the future of heating to fight the global warming. This challenge competition is, we are searching for solutions for us, but at the same time, this is a risky project in terms of whether we really will manage to find solutions that are suitable for the city of Helsinki. We have a strong belief we will, but at the same time, as we put so much time and effort on this whole process and this whole competition, we are very committed to make sure that we share the knowledge and the solutions and all the innovation with the other cities around the world. I would say that it would be irresponsible of us if we wouldn't do so. And of course, it goes without saying that all the business secrets of the teams who will join the challenge are, of course, respected. The competition is global, so all the teams from around the world are welcome to join the challenge. And the main award is €1 million. The next slide, please. We welcome different kind of solutions and different types of teams do this challenge competition. The competition indeed is open for teams with minimum 2 team members, and but we encourage to join the team in large and more diverse teams. We get a lot of questions on why we decided to do that, and there are multiple reasons for that. But we truly believe that the best ideas are born in cooperation between the different innovators. When the innovators and the solution providers also challenge their own ideas, when they come together, they might come up with the solutions that they wouldn't in their own silos. At the same time, our challenge is big, so it takes a lot to solve it. So therefore, we aim to bring people together with various different backgrounds. And the feedback that we have got so far has been that even during these challenging times, this challenge competition has created a positive atmosphere around the world and has brought together people with different backgrounds. And that's, of course, extremely good feedback for us. That's what we are aiming for. And we welcome different types of solution. It's good to keep in mind that this is a design contest, meaning that we are searching for the plan, the master plan on how to reach our how to decarbonize our heating system. That means that one competition entry can include one solution, very impactful solution, hopefully, or it can include several solutions that might be complementary to each other. They could be technological solutions, but they can also be non-technological solutions. So the key is that we give you the facts of the current heating system, and we give you the evaluation criteria and what are important aspects for us, that we do not want to limit you when you brainstorm the solution for us. Next slide, please. Shortly about the process and the timetable. I see the words have been jumping around a little bit, but that's okay. This is all available on the challenge website as well. We are right now having the application phase. It will continue until the end of September. We decided to extend it a little bit due to the COVID-19 and the difficult situation that all of us are currently living in. During this application phase, we were supposed to meet many of you in your respective countries, but of course, due to the circumstances, all our events were cancelled. But luckily, we have managed to run several webinars and other online events in order to create discussion around this important topic. We have published on the challenge website the report describing the current district heating system, and the Finnish and Helsinki specific situation, or the Finland and Helsinki specific situation. It should be enough as a background information to prepare your application, but of course we probably have missed out some information that is relevant for your idea, and therefore you can submit your questions through the application form on the challenge website. But please keep in mind, I think we take the questions till end of August, and after that it will be closed, so to give all the participants the same possibilities. And all the questions and answers are published on the challenge website. In October, we will go through all the applications. We have got many, and there are many in preparation. Of course, we are looking for the quality, not the quantity, but we know already based on the feedback so far that it will be a difficult task to evaluate all the solutions. Therefore, we will not do it alone. We have a dedicated team of external experts, who are independent from us and independent from our energy company, who knows the Helsinki and Finland specific situation very well. So we will listen to them to make sure that we select the best teams and their best ideas to continue in the process. But those teams who qualified for the second phase will be informed by 6th of November. Next slide, please. We start with an orientation webinar where the finalist teams, minimum 3, maximum 15 teams, will be selected. We will give instructions for the second phase, for the final phase. The team can also express their wishes for us. So what would they need more from us in order to be able to make a further elaborated solution for us. And we will also advise the teams on where should they sharpen their idea for Helsinki specific context. We hope to meet everybody here in Helsinki in December. So not everybody, but the finalist teams. And of course, due to the current circumstances, as it looks now might be that we will meet virtually. We still keep our fingers crossed that we could meet face to face, but if not, then it's going to be a virtual boot camp. So the dates will not be changed anymore. So this is the timetable that we will keep, regardless how the COVID-19 situation will evolve. During the bootcamp, there will be common program for everybody, but there will be one-to-one meetings and tailor-made program for each team. So each team will get to meet different type of experts depending their own needs and wishes. And we aim to give the information that the teams need in order to finalize their idea. After the bootcamp, there is 1 month time to finalize the proposal. So January 22nd is the deadline then for the final proposals, but detailed instructions will be given for the finalist teams. In February, we have an expert panel who will decide on the winner. Important to notice that that panel is different than the one who helped us to make the selection on the finalist teams. We want to make sure that we are using experts in every stage of this process. but also why it's different team is that the winner will be selected anonymously. So the jury will not know which finalist team is behind which finalist proposal. So they will purely evaluate the impact, the solution and its impact, and not the team. In March 2021, so next year, we will celebrate the winners, and more on that at the later stage. Next slide, please. We have set 7 important evaluation criteria, which are climate impact, cost impact, impact on natural resources, the capacity of the proposed solution, its implementation schedule. We are looking for solutions that could potentially be implemented by 2029. Implementation feasibility and reliability and security of supply. All the criteria are equally important, so there is no weight on any of the evaluation criteria. And Eetu, if you take the next slide, it's a horrible slide. I know I will not walk it through, but it's just all this information is on the competition material. But just briefly to explain that in your applications that you are now preparing, you should keep in mind that it's an application to impress us, but it can still be your preliminary proposal because you get more information on us if you will be selected as a finalist. So in the first, for example, with the climate impact in your application, you should describe the estimated impact on our emissions. Whereas if you are selected as a finalist in your final competition entry, we then start to ask a little bit of more of an analysis. But at the same time, we also help you and we give you a further advice on that. I saw somebody was asking about the slides, and yes, you will get the slides too. Next slide. I know I'm over my time probably already. High profile jury, independent from us, will make a decision on the winner. So they will go through the finalist proposals. We have very top experts from Finland. Markku Ollikainen, who is the chair of the Finnish Climate Change Panel and a professor from University of Helsinki, and Sanna Syri, who is an energy technology professor from Finnish University. We have another Nordic expertise from the University of Aalborg, and then we have also other international expertise from MIT and from World Energy Council. And we will add experts to this jury once that we know what the finalist proposals are all about. So at that stage, we will make sure that all the expertise that is required to evaluate the final proposals will be represented. And next slide, please. I am trying to speed up. More information available on the challenge website. There is also a link to the collaboration platform that some of you are familiar with, and Eetu will probably talk you more later on. You can continue the discussion there. That's a platform to support your team formation and to support your discussion. But keep in mind that the information that you should familiarize yourself when it comes to the challenge is on the energychallenge.hel.fi, as well as the link to the application portal you will find there, not from the collaboration platform. That's for before submitting your idea. But now I hand over to Kaisa-Reetta, who will explain a little bit about the current district heating system. And Eetu, it's great if you or somebody who is helping you will help to change the slides for you, as I promised to Kaisa that I would do it, but I seem to be handicapped still.
Of course, Laura. One quick question in between. There was a question on the chat that I think it was Nikita who asked, would there be any option at some stage to share Excel files rather than PDF or JPGs, as they would help their application entry with the calculations and everything to be on an Excel sheet?
In the application portal, it's indicated which attachments are allowed, and we will not change that anymore. So I believe you can have to take PDFs from your Excels. It's also good to keep in mind that in the application portal, the information that is submitted in the question fields, that's the core what will be used in the evaluation. The attachments are just more to verify the answers. So make sure you impress us in your question fields, not in the attachments. Those we will use if clarification is needed.
Thank you, Laura. And I think it's Kaisa-Reetta's turn to get into the background of what is the situation with the Helsinki district heating at the moment.
Oh, yeah. Can you hear me just fine?
Yes, indeed.
Okay, very good. So my name is Kaisa-Reetta Koskinen, and I'm leading a carbon neutral Helsinki project. So basically, it's my task to make Helsinki carbon neutral by 2035. And next slide, please. Okay, and as Janne and Laura already said, we have a very, very ambitious target. We want to cut our emissions by 80% by 2025. As we have already come down around 1/4, a little bit more than 1/4 of the emissions, we still have a lot to do. We have to do more, we have to go faster, and because the difficult task, so to say, they are still ahead of us. And we have an action plan, as our mayor already mentioned, and it's called Carbon Neutral Helsinki. It's a very comprehensive plan, so it's covering all the sources of emission, both direct emissions and indirect. And we have a lot of actions, more than 100 actions ongoing already to achieve our target. But as Laura and also Janne already mentioned, the biggest source of direct emissions in Helsinki is the heating. And the competition is one tool to tackle this heating challenge. But as a part of the carbon neutral program, we do a lot more. And so we, for example, on the consumption side, we have a target to reduce the use of district heating by 30%. And this is basically mainly done by increasing energy efficiency of the building and increasing the role of the renewables. So basically it's geothermal and heat pumps on the building level. So on the consumption side, we are already doing a lot. So the biggest challenge and what we don't know yet how to solve is the production side. And so it's good to keep this in mind, when you are preparing your proposals. Okay, the next slide, please. And this is the energy system in Helsinki at the moment. The system is operated by a company called Helminen, and the company is fully 100% owned by the city of Helsinki. The district heating is a main heating form in Helsinki. More than 93% of the buildings, the number of the buildings is connected to the district heat system, and more actually, on the population level, it's even more, because the 7% of the buildings which are not connected to the district heating system, they are the single family house or the very small houses in Helsinki. The system is basically, located inside Helsinki. There are small connection points to the other systems, but basically it's very Helsinki-centric system. The backbone of the system is 4 combined heat and power plants. So it means that they are producing heat and they are producing electricity both. 2 of them are burning coal. As our mayor already said, the first one is going to be shut down in 2024, and the second one is going to be shut down by 2029 latest. There is a national law which bans burning on coal, and after that, and that's why we have to find a ways to close that coal plant down. The other 2 combined heat and power plants, they are burning gas, And so they are basically these 4 plants at the moment. They are the backbone of the system. They are generating 90% of the yearly need of the district heat together. So additionally, we have 2 quite big heat pump stations. The other one, the Katri-Vala heat pump station, is actually the biggest 3-generation heat pump station in the world. We are very proud of that. It's basically pumping heat from the wastewater treatment plant, so from the purified wastewater. But still, these 2 heat pump stations, they are only 8% of the production together. So it's a fairly small share of the total heat need we have here in Helsinki. Biomass at the moment is 3% of the heat production. The biomass is what we are using at the moment. It's the wood pellets. And then we have 1% of the fuel oil burning stations. They are basically the peak load heating plants, which are in the picture. You can see the peak load plants. There are 11 of them, and as you can see, the capacity of those plants, it's very big. But we are only using them on the very cold winter hours. So the heat generated with those is very small. It's basically the 1%. We also have a heat storage on the system, and if you are interested, the temperature of the system it varies between 65 to 115 Celsius degrees, and it's mainly depending on the outside temperature. And so the next slide, please. And this is just the picture of the heat need variation through a year. So we have the cold winters here in Finland, and during the winter months we need a lot of heat. It basically, when we have the peak hours on the coldest months, we need all these plants to produce heat. During the summertime, during the month of July, it's 1 or 2 combined heat and power stations are enough. During the summertime, we don't need the heat for the heating of the buildings, but it's mainly domestic hot water what we are producing during the summer months. And so I was only given 5 minutes, so it was a very, very quick. But we have a lot of background material in our webpage, and so there is this kind of heating system in Helsinki background material, and you can find all the numbers and exact figures from this material. And also, we have answered many questions during this challenge already, so it would be a good idea to go through those question and answers. So maybe somebody has already asked your question during this challenge. But thank you from my side, and hope to see many of you as a finalist here in Helsinki on December. And so.
Thank you very much, Kaisa-Reetta. It was good to hear all the background, and I'm sure it's very helpful for all the willing participants and application makers. And now it's actually my privilege to host a discussion, and this discussion is a lot about how to build innovations and how to build teams to make the innovations more impactful. I'm happy to invite 3 really good experts on the issue. First, Marcius Extavour. He's an executive director of price operations, energy and resources at XPRICE. The other one is Jukka Leskelä, managing director, Finnish Energy, and also the third one is Vesa Silfver, managing director of Motiva. And Motiva is a state-owned sustainability company in Finland. So please, could you turn your microphones and also your cameras on, gentlemen?
Sure.
Now, my apologies for the all-male panel. These were the experts that we were able to get for this, and there's no mean for being all-male panel at that. Marcius, you're an executive director at XPRICE. Could you explain what you do?
Yes, certainly. Thanks very much, Eetu, and great to be here with you, everybody. I had the pleasure of hearing about this challenge maybe last year or when it was in the planning stage. It's really exciting to see it come together, and I look forward to seeing all the great ideas that will come forward. I'll also just share that I'm from Canada and Toronto originally, so I can absolutely relate to the challenges of a climate that's warm in the summer but very cold in the winter, district heating, different heating options, etc. A lot of similarities there. So as has been mentioned, my name is Marcius Extavour. I work at XPRICE Foundation, which is a nonprofit based in the United States and California, and we focus on exactly this type of approach, using the incentive prize competition to try to drive solutions and support innovators to solve big problems that can have broad benefit for humanity. The challenge of heating, as it's been laid out for the city of Helsinki, is something that can actually be applied to many other cities, frankly, across the entire Northern Hemisphere, whether it's a temperate city or even a very cold city. My specific role at XPRICE is to look over all of our energy, climate, and environment related work. I focus on demonstration competitions. So we tend at XPRICE to operate demonstration competitions where we want to see a full solution deployed. In this case, it's probably not possible to ask somebody to deploy a full solution to a city. That wouldn't be appropriate. But I'll say that before I close my introduction, that I just have a lot of experience in trying to think about how to structure challenges, but also with the type of collaboration it takes to bring an innovative idea together to solve a particular problem like this. I look forward to the discussion.
And next one, Jukka Leskelä, who's a managing director at Finnish Energy. Jukka, how would you describe the Finnish energy scene?
Thanks, Eetu. It's very nice to be here with you discussing on this issue. First, about Finnish Energy, we are an association of Finnish energy companies representing the district heating companies, but also electricity companies and gas companies here. And about the energy system in general, I would like to say that we are in great transformation of the energy system as a whole. There are actually two major changes going on. One in the generation side, where we build climate neutral generation of heat and power and also gas. And the other major change is happening actually with in the customer side. There's the digitalization going on, and also a lot of new technologies and services that the customers can benefit from. And it's really interesting to see what's happening in both ends of this system. And when you combine these two major changes, one in generation and one in the consumption side, then you end up in having the system integration or sector integration or whatever you call it. Very popular issue nowadays, but the fact is that the heating system, the electricity system, the industrial energy system, the transportation energy system, and the gas system, they are all about to combine, and we need a lot of data, and we need a lot of new technologies and strong networks to make that happen. And that's highly interesting, and I love to follow this all.
Okay, I'm glad to hear, and I'm sure we hear a bit more about it as well later on in the conversation. And then our last conversationist, last panelist, Vesa Silfver, Managing Director of Motiva. You are a sustainable sustainability company and also dabble something with energy scene. How is your work related to energy?
Thank you, Eetu, for inviting me here. So yes, Motiva is a state-owned sustainable development company, and we were founded as an energy efficiency competence center 25 years ago already. So we're an in-house company for government, and we actually facilitate collaboration across both the government, municipalities, and different industries. For example, in gaining energy efficiency improvements, and one major instrument is energy efficiency agreements with major industries in Finland. But we are also supporting various initiatives that the government has in transition to clean energy. For example, getting rid of oil and so on in heating. But my personal background is actually with global consulting companies. I was with Accenture and Deloitte last 15 years. So I'm optimist in the way that I believe if we can just use human and planet-centric design and innovation, we can actually sustain our planet for future generations in days when there is quite a lot of worrying signals in the air, both from climate change and corona lately.
Okay, in this challenge, in the first phase, we're talking a lot about ideas and how to, as Laura said in her presentation, that how to really impress the jury. How to work on an idea, to make an idea to an innovation and then to an executable solution and concept. I think, Vesa, you're good to continue this one because I know you're working a lot with scaling up at the moment.
Yes, so we helped the Finnish government in developing an approach. It was called in Finnish kokeiluista skaalaan, so from experiments to scale. And one of the challenges I have seen myself is that we are doing a lot of pilots one after another, and we are kind of sometimes failing to change the larger systemic challenges. And that's why we build the approach which kind of guides both the government and the local actors and the private sector to start from the bigger picture and then identify the problems that we need to address, and then the actors who could be joining up forces in creating the solutions. And I think these kinds of challenge competitions are a great way to attract and combine those forces.
Markus, you've got a big experience on this one, running different challenges. How do you make it work so that it comes from an idea to an innovation and then to an actually executable concept?
Yeah, it's a great question. I think I'll comment on the beginning part of it because I know we're in a phase where there are a lot of people probably on the webinar and in general who have a lot of ideas and concepts. And one of the most interesting parts about this challenge is the emphasis on collaboration, which I think is fantastic. One piece of practical advice I'll give is to, if you're out there with a concept or an idea, sometimes we tend to, especially in a competition format, we tend to want to keep the idea to ourselves because, look, you're trying to win. But there's another way to think about it. And I would suggest consider telling as many people as possible about your idea. Yes, there is a risk that someone will quote unquote steal it, but I think it's much more likely that you'll get a lot of feedback quickly. And you'll get a lot of quick feedback from other people who will, just by their reactions, whether they will tell you whether they think it's sort of a boring idea or if they're intrigued. And even this could be people that you trust and know. It could be other people you're considering partnering with. So I would say resist the temptation to keep your ideas only to yourself. And really, maybe there's a small circle of trust, or maybe it's very broad, but consider sharing your ideas broadly as you can, because that will lead to better ideas, more information for you and your concept. And hopefully, ultimately, a winning team and a winning concept. And then the second thing I would say with respect to taking an innovation all the way from a concept through to a deployable solution is always think about the end users in mind. So for instance, the heating business, utility business, energy business, has certain structures and rules. I'm not saying you need to master all of those, but always remember who the end users and the end customers will be, even at the very ideation stage. Just sort of keep that in your mind. It's very easy when you're thinking about new ideas and technologies to come up with what we call a great solution that's looking for a problem. make sure you are doing it the other way. Make sure you're focused on the problem as it has been well defined in this challenge, Helsinki heating, and make sure that your ideas are always connected to that, so you don't get into a place where you're actually moving in a direction that could be great but not relevant for this particular challenge.
Take a different point of view. I think you mentioned on building a team and then coming up with an idea. Is it possible to just simply build up a team with good minds and then sit down, come up with an idea? How would you proceed with that?
Yes, absolutely. So one thing we have done at XPRICE sometimes is to try to do what you're doing here and create a collaboration platform early in the challenge, intentionally to help people come together. And we usually say, listen, if you have a great idea already in your mind, great. And you already have a team, fantastic. If you only have a team and no ideas, that's fine. In fact, most people that are looking to, sort of from an investor perspective, something we hear a lot in the United States is investors are more interested in the team than in the idea, because a great team that clearly knows how to work together and is collaborative can solve many types of problems. So that's quite important. And then even as an individual, if you have an idea or not, but you just would like to be part of a team, I think there are ways to get involved here as well. So it doesn't have to, don't think that if you don't have some kind of genius idea in your mind now, that you cannot participate. It's the opposite. Ideas can come from you or other people, and absolutely focusing on a team first is a totally fine way to do this, I think.
And now I can promote the collaboration platform a bit. There's already some good conversation and some good ideas being thrown around, and you can definitely find at least some other people there who are interested in helping you and helping themselves to really answer the challenge and make an application. Jukka, what do you think? What things do you need when considering recreating urban heating? Are we talking only technology? Are we talking local knowledge, human behavior, maybe even talking about megawatts? Or what would be your approach?
Well, first of all, this is not a greenfield city. There is a heating system already existing. And this is, of course, highly important to understand that there is a lot of infrastructure already in place. It's highly important to utilize the existing infrastructure in order to keep the costs low. And of course, while we have in Helsinki already, as it was said, 93% of heating is already connected, then you can actually create a system where you can move the energy from one place to another. And you should consider the system, not individual technologies. Also flexibility. A little bit unlike Marcus said, I would encourage to look a little bit larger than heat only. Consider also the power system and probably gas as well, because there is, as it was mentioned, there are already gas power plants and there is a gas system as well. So there is existing infrastructure. And also, in addition to have this system approach you should also consider the customer. This is not only, or the future energy system will not be only selling hot water to the homes. It should be much more. It should be engaging the customers to the system and encouraging them to make their part in the system. And they will do it only if they will benefit from that. So system, existing infrastructure, and customers. That's my advice.
Vesa, I know you're coming from an innovation point of view, largely into many discussions. Jukka just said that you have to reconsider and think of the existing conditions. Is there a way of forming an application, forming an idea of considering the whole thing as a greenfield?
Yeah, I think it was good emphasis that Jukka said that there is the whole production system in place, and I think this change happening both on the energy generation side and on the customer consumer side to new digital solutions, and people start being more ready to adopt new types of services. I think this is there is a good cue for some innovative ideas. So have we actually built within our energy system kind of inherent wasteful patterns which are either on production or on consumption side, and can we somehow help with those innovations also in alleviating the problems with the peak consumption and the higher kind of carbon emissions that happen during those hours? And actually what Jukka said in the end, how to engage people better to be active participants in solving this. So can we help them somehow make their personal choices or their personal investments even in solving the challenge? So here we come kind of move away from the big energy companies making their individual choices on how to build the power plant and so on, to having this energy system and having a lot of distributed decisions also happening. And this is an interesting aspect for me.
Marcus, from your point of view, I'm trying to emphasize this because from my point of view, you can always look at the radical solutions as well, and you might find something new if you're looking at the radical solutions. Do you think there is a way to come up with a radical solution?
There always is a way. Energy innovation is particularly challenging because of the points that have just been mentioned. You always have a lot of incumbent infrastructure. You're not starting from scratch. You're not starting from a blank piece of paper. We're not just going to throw away those assets. On the other hand, if you only focus on the existing infrastructure, nothing ever changes. So this is one unique challenge to energy innovation. And it's unlike innovation in other types of areas where it's a little bit more greenfield, or you don't have, let's say, billions of dollars of assets already in place. One thing that I think is helpful, though, even in sort of a very constrained view of the energy system, and I don't think it is actually that constrained, even then, focusing on what seem like ridiculously impractical ideas, sometimes, even if you just allow yourself to do that for a little bit of time, it can expand your mind and your thinking. So you explore an idea that seems crazy, and maybe you only sort of go 10% in that direction, not all the way to 100%, which might be completely crazy. But what I'm saying is, don't be afraid of the crazy ideas, especially in the early stage. Do not dismiss the crazy ideas first, because perhaps they hold a lesson that can take you in a new direction, even if they're not implemented in their sort of fully unbaked form. It's still helpful, especially at the early ideation exercise. So something to think about as you're forming your teams, putting ideas together. Look, sometimes bad ideas are just bad ideas, that's fine. But sometimes there's a glimmer of interest there, and especially in energy innovation, where we know we have this particular challenge of existing infrastructure. Don't be afraid to at least think about those ideas a little bit and see what lessons you can take to work them back into something that you think is actually implementable.
Sorry,
Right.
Eetu, can I very quickly comment on that? Could I just continue what Marcus just said? Indeed, from the organizer's perspective, you need to consider the current facts and the current infrastructure, but don't be limited by those. So really be innovative, consider those, take them into account. But we as an organizer and the city of Helsinki, we haven't set any limitations on what those solutions could be. So really challenge us, challenge yourself, and impress people here in Helsinki and here in Finland. We tend to only see the limitations, and we believe that the rest of the world can perhaps help us to see outside those limitations.
Thank you, Laura. And now we're going into how do you get to those impressive solutions, because one thing that the Helsinki city has really emphasized is that you should team up, you should form consortiums, teams to make really impactful solutions. So you actually have to have minimum 2 participants in the application. Why is it so important to team up? I think, Marcus, you touched on this a bit. Can you elaborate?
Certainly. So for very practical reasons, one, share the workload. But for sort of more intellectual reasons, diversity of ideas and opinions. All of us, no matter how much or little time we've spent thinking about energy innovation, we can get stuck in our own thinking patterns. And working with other people not only helps you work more quickly, but it helps you challenge your own assumptions. And that's especially helpful. I'll go back to a point that was made before, and what Laura just mentioned. We want to be thinking unconstrained. There are some constraints, but we don't want to be sort of bound and shackled by them. And sometimes bouncing an idea off of one or two or three other people is just a perfect way to go. I mean, I personally work much better when I can have one or two other people to talk with. No matter how smart I think my ideas are, they're always better when I talk to somebody else, because they tell me when I'm being ridiculous and they add something else and I learn from them, and I find it just goes much more quickly. And I think is just a little bit more fun. So, I think these are kind of obvious points, but all good reasons to think about building a team, no matter how clear and formed you think your idea is. I'm not saying somebody else has to come and change it, but even getting feedback from another person is another way to work inside of a team. So I strongly recommend it.
What would be your insight, Jukka, on why is teaming up so important, especially in this kind of a challenge?
I agree totally with Marcus, and I would like to say that simply the challenge is quite complex. I don't think Helsinki is expecting to have a very simple solution with changing coal to something else. I believe that they are seeking for really fresh ideas with some a little bit more futuristic ideas on how the whole energy system will work. In the end, I believe that on one side there is a competition who wins the competition, and there are certain rules, and in the other end that there is need for fresh ideas that could be used in parts, could be used somewhere else, and this would be a great place to raise new ideas, and teaming up is really improving all the ideas, as Marcus said.
All right, when you are actually teaming up, Laura said in her speech, her presentation, that this is about the time to impress the organizers, and then you start working on the ideas. Jukka, what would be your advice? What kind of partners would you look for, and how would you go about it?
Well, you need a partner who understands the energy, the heating system, and what is needed there. But then you need some other guy who understands something about the maybe on the flexibility or data or customer behavior or whatever. But consider having very different partners in the team. That's my advice.
How about you, Vesa? What would be your advice?
Easy to agree with Jukka's suggestion. So you need to have the substance knowledge. You would possibly have a digital elements to the solution if you want it to be very scalable. Also in changing human behavior, unless it's on very heavily on the production side alone, the solution. So you need those aspects. One thing is interesting how the large organizations and the smaller ones could collaborate in these challenges. So large organizations often have the innovator's dilemma. Can you actually rethink your own business? And small organizations can be very innovative. So maybe you would benefit also from looking at the Finnish and in other countries also the scene of different companies, whether they're looking for lean and agile startup ways of innovating and data-driven solutions and collaborating in open innovation with other companies. So if you're a small company, look for cues from their strategy, to put it simple.
Markus, a challenge is a very particular type of work. In this setting, how would you go about finding a team?
Yeah, that's a great question. There's a couple of ways you can do it. One, you can, if you feel like you already have people in your network that you know and trust, your friends, family, colleagues, and it's pretty easy what to do next. You just call them up, send them a text, ask them, introduce them, see if you can make a team. That's sort of a pretty typical way. Another way to do it is to take a team that you might have already formed in the past or currently from another project and think, well, maybe we did really well together and we'd like to continue working on a new topic. The way my workplace is organized is a little bit that way, for instance. And that's one of the things I think about is, should these 3 people move on to another project, or should we sort of divide up into new teams? But let's say you're just an individual and you don't really have a team. One thing I think you should do is you have to just be a little bit honest about what you know, what you don't know, and what you're looking for. You're looking for a complementary piece. So it can feel a little bit vulnerable or exposing yourself. But for instance, you might say something like, I come from a more technical background. So I might say something like, well, I'm a deep technical expert, but I've never fundraised for a business from scratch. So I could really use help with somebody that knows how to raise money. And I am not a policy expert, so I'm looking for somebody with help from that direction. In other words, it's okay to say what you don't know, because that might be an invitation for somebody else who is a complementary team member to come in, and then maybe you can start a conversation on that basis. So I guess being open about what you think you need and what you think you already have, that could be a good place to start a conversation.
How important is it to have a member in your team that disagrees with you?
That agrees with you?
No, that disagrees with you.
Oh, fairly important, I think, but you want somebody that you can disagree with in kind of a respectful way. If you're just arguing, it's going to be a disaster and you're going to hate it. I've seen teams like this. I've been part of them, right? At the end of the day, if you every time you meet with this person, you're just disagreeing all the time, you're going to become frustrated. But if, and maybe it's just, you can't work together, or maybe it's, you're not sort of approaching it in a sort of respectful way. And I think each person sort of knows how this works. I think it's okay to have ideological disagreements. The key to managing disagreements and tension is everyone has to be committed to moving forward, for instance, together. So you can have an argument and then, or a debate, and then decide, well, it's her decision. This part of the project is her decision, and she's going to make the call. And if everybody's okay with that moving forward, then great. Then you can manage those disagreements and have a team. But if you feel like the disagreements create too much tension, and even after decisions are taken together, they're never really resolved, then you have something to work on, either your decision-making process or maybe even the team makeup. So I encourage you to look for that, but it's harder to find a constructive team where you have disagreements. I think it's more productive, but there's a reason it's a little more difficult, because it's just a little more difficult to manage interpersonally, but definitely worth pursuing. I'll add one other point here. One thing you could do is, let's say you have a team where everyone does agree all the time. You don't necessarily have to have the disagreeing voice be part of the team if it doesn't work out to manage it that way, but you should seek them out. So could you spend, approach somebody that you disagree with, could you spend an hour critiquing our idea with us, please? They'll give you a bunch of feedback and then you take it. It doesn't mean you have to sort of have that be part of the team continuously, but you should still seek out alternative viewpoints. As a consulting type of thing. Just find a friend or somebody else for 30 minutes or 1 hour.
I'm going to be ending this conversation sadly in a minute. I think there's a lot of good points coming out, but I'm going to be finishing it with the last topic, and I think it's probably the most pressing issue, and it's impact. And I know every time everyone talks about having an impact and is looking for, and as Helsinki is actually looking to get rid of coal by 2029, or Finland, and also Helsinki is on the journey to becoming carbon neutral by 2035. In creating the applications, the new, maybe even radical solutions, Jukka, what would you think? How would you look at impact? How would you look at its impact, the solution, the applications?
Well, of course, it's highly important that it's really reduces emissions significantly and solves Helsinki's challenge for the carbon neutrality from the heating point of view. But as the energy system point of view, I would like to see proposals that whenever you build something new in the energy system, that's for tens of years. So, and Helsinki is not a dead city. It is growing, it's developing, and the energy system is still developing after this, and there will be always need to change it. So I would also have a look on how much you can change the system that is proposed, and what kind of elements is possible to include in the system once it has been built.
Vesa, could you start the whole innovation process by defining the wanted impact first, and then you start building the solutions that you want?
I think looking at the challenges that we are facing, there was also comments that shouldn't only focus on heating, but also electricity. We should look at these carbon emissions and all these challenges as a whole, and also start thinking from there what are the most impactful solutions. And I think we are still only one capital region of some more than 1 million people. So can you actually create solutions that are scalable also across our country boundaries? I hope the jury will also appreciate this aspect in that scale quite a lot. So in this sense, can you build solutions that can be attached to many different energy systems around the world in the cities? Mr. Mayor was emphasizing this, that we are building solutions also for other cities in the world. So that would be really cool if you can build kind of concrete calculations about this sort of impact you could have in capital region, but also that it wouldn't be totally nailed to our local reality, but could be scalable in other cities.
Marcus, I think you're going to have the last answer here. With the challenge competition or challenge like this, how would you define your impact has been good enough? How have you been successful when you're ready? So that lends to those who are thinking of applying. What do they have to think of that when they're submitting their application, that one you should be satisfied with it, with the impact that it's going to bring to Helsinki and hopefully the larger world?
Yeah, thank you. I completely agree with Jukka and Vesa on this point. I will just add that sometimes I think we are all here thinking about this topic on this webinar because we're interested in having a broad impact globally, in the city, locally, etc. Sometimes thinking about the broad impact of energy transformation and climate change can be almost overwhelming, but I think it can be motivating. My advice is to remember that your solution can only have impact if it works and if it's actually scalable. So that's a way to bring it down to something more focused and practical that you can work on. It has to be deployed. What will n equals 1 look like? What will n equals 2 look like? Before we think about n equals 1 million, we want to get there, but it starts with n equals 1. And so make sure that you have a clear vision of how that can happen, because without that, you absolutely cannot get to n equals 1 million and the big scale we want. So that's a way to kind of, for me, to take the pressure off of scale and focus on what can I actually accomplish that is real and that will work, and that there is a plan for how it could grow.
And with the challenge, it starts with actually submitting an application, doesn't it?
Exactly right.
Because if you haven't submitted it, there's no way it's going to become reality. All right, I have to thank Jukka, Vesa, and Marcus. I think it was a good discussion, and also we touched on the main issue, which is teaming up and how the teams can really improve the applications and also in the end make a bigger impact. And now we're going to have 5 different ideas, 5 different proposals that are looking for team members. They are Ebrahim Takoila from Green Hydrogen Solutions, Zvika Klier from DigiSolar, Virgil Perryman and Shiva Venkat from Perryman Technologies, Paul Klinkman from Klinkman Solar Design, and Matus Kaidos from GA Drilling. And please, Ebrahim, starts.
Can you all hear me and see me first? Okay.
Yes, we can.
Okay, great. So you're projecting my presentation. Thank you very much. Yeah, okay, so to go ahead, thank you for the time to present. From our understanding of the challenge, we will present a green hydrogen roadmap in support of Helsinki's vision to be carbon neutral by 2035 and have 0 carbon emissions by 2050. Our solution takes into account ways to replace coal with carbon neutral and low biomass solutions, which is what the brief is. So if you go to the next slide. Thank you, the next slide, yes. Green hydrogen is a heating solution if you consider electricity and heating as energy, but in different forms. Advances in technology have led to significant innovations that improve the efficiencies of electrolyzers, thereby reducing costs. But the key challenge remains finding renewable energy for a sustained duration and linking green hydrogen to markets. And that's what our solution really looks at. It looks at technology to link the system. If we go to the next slide, just provides an overview of what we do. We combine big data and artificial intelligence with innovative technologies to develop lower than average cost projects that produce hydrogen at competitive prices linked to demand. I know that's quite a mouthful, but it's a way that describes the neural network that we are developing, which you can find some information on our website. The global neural network will link renewable electricity and markets, and I'll show some slides later on that. So if we go to the next slide, so how is green hydrogen a heating solution? If one considers electricity and energy as heating, as I've done in the past, but in different forms, then one can solve for a simple equation. Due to the difference between peak demand and low demand, heating can be used when it's needed and stored when it's not. So if you go to the next slide, this is where a balanced, efficient system powered by renewable electricity and using hydrogen as storage will solve the equation and the heating problem, along with other heating solutions. So if you look at the storage potential when energy is not being used, that is certainly a way to look at heating. If we go to the next slide, so if we look at the ecosystem, the hydrogen ecosystem is undergoing rapid development and will over time have the capability to modernize and transform the energy ecosystem. From all the green hydrogen apps, which we call them, available to address the energy challenge, we can choose those that address certain key energy challenges, all backed up by data and information. So what we choose and the solutions we choose will be backed up by a significant amount of data, which we will have in our system and which we'll collect from different areas. If we go to the next slide, yeah, the key challenge is securing low-cost renewable electricity for the longest hours and linking that to production. This is where our solutions using artificial intelligence deployed to a smart, integrated electricity and heating system and an energy system can solve the problem. So if you look at this slide, one of the things that was mentioned was incumbent infrastructure. So here we can use existing pipeline networks, we can use existing heat networks, And we can also look at modernizing some infrastructure. So what we're looking at doing here is putting some information related to data centers, probably bus and trucks that could run on hydrogen, and in the long term, maybe ammonia for shipping. And this just provides a general overview of the entire system and what could potentially work. And if this is developed, it would be backed by data. So going to the next slide. So what we are looking for is a partner. The Helsinki Challenge is an excellent use case for our technology. We would be looking for a partner that understands Helsinki, meaning having some local knowledge and experience. We would like to develop a pilot project. As you know, green hydrogen is in development. So the best way to develop it is first to take a first step with a pilot project and test a lot of the use cases, and then move forward to something on a larger scale. So we have a 3, 5, and 10-year point of view. And then we see the value of green hydrogen in the future energy system as it develops. And we would be looking to collaborate beyond the Helsinki Challenge. And I thank you very much.
Thank you very much, Ibrahim. And next, we will have Zvika Clear. Did I pronounce it right, Zvika?
Exactly right.
Thank you. Zvika's not having slides. He's brave to talk without slides.
So I hope that you can see my video. My name is Zvika Clear. I'm CEO of Tigi. Tigi is a provider of relatively large commercial and industrial heat systems. And we do that primarily by using a new type of solar thermal collector that we developed, which is especially efficient in cold climate conditions and for relatively higher, again, commercial and industrial target temperatures. The basic technological innovation and technology here is related to transparent insulation, which minimizes energy losses and improves efficiency. This is something that we're already doing. For the Helsinki project, we are proposing adding a dramatic amount of renewable energy of 2 different sources, one being solar thermal collectors, the other being wind power that is pushing or providing power to a large additional heat pumps. The heat from both the solar thermal collectors and from the heat pumps and from additional sources will go to a large water energy or water heat storage, thermal storage in water, which is a large solar pond that will also be covered by transparent insulation. This will be stratified and we will be able to make sure of 2 things. First of all, while this storage of heat is losing only a minimal amount of energy back to the environment because it is insulated on the sides and below, but also with transparent insulation on top, it is also gaining energy. So overall, the energy of this solar pond is positive year-round, rather than managing only losses. What we are already having in our team is Tigi with this solar thermal knowledge and this background with solar ponds like this. We have another team member from the Fraunhofer ISE and another small Israeli company with background in optimizing between heat sources and control, primarily using heat pumps. Where we think we could get additional help from other team members would be, first of all, from local, I prefer, architects, because the large areas that this will take, including the solar pond, can be used as public spaces and And on the side of the combination of architecture and the structure and infrastructure, we would be happy to have local partners. We would be happy to get partners on the side of renewable power, wind preferably, and also if there is a local engineering university that would like to join forces, we would be very happy. My email does not appear here. I don't know how you'd approach me. I guess through the organizer, maybe Eetu can get this, or if you put your email now on the chat, I will see it. Happy to join forces. I think this can be groundbreaking. Thank you very much.
Thank you, Zvika. And also there is definitely a way to approach you. Hopefully you can all join the collaboration platform. I will share the details at the end. And now we have 3 more presentations left. And the next one is Virgil Perryman and Shiva Venkat from Perryman Industries. Please, Virgil.
Gentlemen, thank you. Could you put the first slide up? This will give you some background information on how to reach us. I thought that would be good to start off with so you knew where we were and how to reach out to us. Next slide, please. Right here, we're showing you a picture of how our heat storage works. We use a phase change heat storage, but instead of using things like molten salt or even water, what we do is we use molten metals. We use different types of metals, and the concept and what we're presently doing comes from observing how the planet Earth holds energy. The planet Earth's held energy for 4.5 billion years, give or take. And it's done so in ways after its nuclear reaction stopped by the many layers of refractory that surround the core. You will notice that in the metallurgy industry, that they use the same concept. And this is where we drew our inspiration from 10 years ago, and we've subsequently been better and better at making these thermal storage units. Now, the good thing about our thermal storage unit, they store temperatures at very high temperatures and at very high thermal density. This means, for example, a unit, one of our commercial units, it's the size of a 20-foot container, can store 11 megawatts and has a delta T between 1750 degrees down to about 300 degrees Celsius. So we're able to at least boil water at the lowest temperatures. The other important thing is we can build these things in larger sizes and larger scales. So theoretically, if we wanted to build a 100 megawatt storage, it would be proportionally larger, but not necessarily more difficult to implement or build. Other important thing is how long we can store energy. We can store energy for months, not weeks, not days. And the main reason is that we allow a small amount of energy to leak out, but the core stays hot and can provide heat for many, many days. We also have a system connected to our thermal energy that we call our solid state, not conductive, solid state thermal conductor. What it does is we use things like graphene and carbon nanotube fiber to transmit the heat at rates up to 5,000 watts per meter. And the interesting thing is we have very small losses with this, and it's very inexpensive when you compare it to steam pipes or other ways of moving energy from one point to another. And as a result, we can deliver energy for kilometers and are not restricted or limited to, having to have the source of energy right in the middle of a city or right in the middle of an area, but we can bring the energy in from where we need it. Next slide, please. Oh, you've gone too far. There we go. Now, people may be surprised that Helsinki and the areas around Helsinki actually have a lot of energy available year-round. This is a graph. It's put together by, I believe it's put together by NASA. I check on that. But at any rate, what it does, it shows the energy bands throughout the planet, more or less. You'll notice the circle in blue. There's between 200 and 300 watts per meter square in the area circled. And that area, of course, includes Helsinki. Now, what happens is this is downward radiation. And there's also radiation trapped in the air continuously. Even in the middle of the winter, even in the middle of a winter night, you'll find this much radiation available. Seldom less than 200 watts per meter square. Now, what we have is devised a solar thermal technology. We call it advanced solar thermal. And the reason for that is we use a coating that allows us to pick up and transmit and concentrate the full solar spectrum. I'm talking about UV, visible, and infrared spectrum all the way through, let's say comfortably 12,000 nanometers. This energy can be concentrated as all waveforms can. And we have dishes that range from a 22.6 meter dish that can concentrate this energy 350 times. So this energy becomes something that can be increased up to temperatures that compare and match comfortably with our existing storage units. So we can take the energy that you have in the air 24 hours a day, we can collect it, we can focus it, we can concentrate it, we can put it into our storage, and this can happen year round. Now, once we have the energy, you know, there's lots of things we can do it. Next slide, let me show something else.
Please, Virgil, could you wrap up quite quickly? We're running out of time.
Right here, right here shows the area that Helsinki's actual latitude, and you'll see that the energy line is slightly under 250 kilowatts at the worst time of the year. So I'm saying we have the ability to provide energy to Helsinki that can be distributed, and we're looking for a partner that would help us implement this technology in a reasonable manner for the city of Helsinki. Thank you.
And Virgil, what kind of partners are you looking for?
We're looking for a partner that basically understands the local infrastructure of Helsinki. We can provide the energy outside of town. We can provide the energy with storage right in the town. And we're looking for somebody who understands the infrastructure and the social nature and the customer nature of how people want their energy distributed, how they want the heat industry distributed, or if necessary, we can basically do it with, and hopefully, with the existing infrastructure.
Thank you, Virgil. Next, we're going to Paul Klinkman. Please, Paul.
There, testing. I'm Paul Klinkman. I'm an inventor from Providence, Rhode Island. My solution is nearly 100% covering the problem. It's well-defined for the Helsinki Challenge. It's inexpensive. I think we can get it done by 2029, and it uses the existing heating system infrastructure. This diagram, I couldn't draw a city, so I drew a house. But we can, it's designed to scale up. We can get great amounts of heat, in other words, high temperature heat, if we reflect and concentrate. My goal is never to kill birds, so always reflect in using only 5 to 10 solar reflections before it goes into a tunnel. Then convert to high temperature molten salt, 400 to 700 degrees Celsius. Store in seasonal storage. Iceland has multi-year storage in the form of lava fields. Then in the middle of winter, in the middle of the night, use hot oil. High temperature might be 500 degrees Celsius to move the heat to the existing district heating stations and to anyone else that needs it. Glass manufacturing plants, for example, need a lot of heat. And they'll move it, they'll create the steam and move it into the house. Let's see. Next slide. The idea of a geothermal, basically holes in the ground, worked in Drake Landing housing development in Alberta, Canada in 2010 to 2015. So we know that below 100 degrees Celsius, it'll work. The trick is going above 100 degrees Celsius. We may need to seal the hot cracks with very hot mineral water. We can use air pressure to keep the air out. We can drain the area. As we get a larger and larger geothermal field, it gets more and more cost efficient. We lose very little heat. We can have multi-years of heat saved for bad winters. Because we're starting with extremely hot heat, we can harvest hot water at the edges and gradually use it. It's a process of going down to eventually to 20 degrees Celsius for heating buildings. But if we start with hot heat, we can, it's very easy to move heat underground. We want to lay the oil pipes to the heating stations. We can accept heat from anybody else. Next slide. We have to cover the 7% of buildings that are not on your system. And to do that, we're going to have rooftop heat grabbing, heat storage in the form of rock beds, and heat pumps for moving the heat from the rock beds into the building. So if the rock bed is, let's say, only at 15 degrees Celsius and the building is at 20 degrees Celsius, the heat pump can still do that. It's much better than trying to use a heat pump to grab heat out of negative 10 degrees Celsius air and move it in. We want 90% efficiency for, in other words, our renewable energy, which we are going to, by the way, use geothermal heat storage for producing. This is a 100% solution. We'll be happy to use deep hole heat and put it in. Show us what you got, 500 degrees, 50 degrees, we'll take anything. Anyways, last slide. I'm looking for a company, and that may be Helen, and that may be Motiva. I don't know these things. I suspect we will still want the coal plants there for 100-year emergencies and for maintenance downtime. It always happens. Other than that, we're not going to burn coal. My solution, we can prototype and then scale up and beat 2029. I don't see anyone else claiming that. Thank you. I have minor management skills. For 20 years, I have been co-coordinator of a mobility access project, 6 paid staff, 30, 50 volunteer drivers, 8 golf carts, 1,200 participants. We move people 7 a.m. to 11 p.m. For 1 week at this conference. So I can do some things. I am 67 years old and I'm not getting up on those, I'm not doing the hammering anymore. So I need all business skills. I need other engineers to tell me that I am full of it sometimes. I need committees to judge between us. Am I full of it? Is the other guy full of it? I need local city planners because I don't know much about Finland. And that's what I have to say.
Thank you, Paul. And I think we're going to be running on to the last pitching presentation for possible partners, prospective partners. Matus, guide us.
Thank you, Eetu. Good afternoon, all. Can you hear me?
Yes.
Perfect. So my name
see
is
you as well.
Great. My name is Marcius Extavour. I'm product manager at the GA Drilling, and our company see a good fit between Helsinki Energy Challenge and our company's mission. And this mission is to enable access to geothermal energy anywhere. Please, next slide. The next one, please. Yeah, great. Probably all of you know geothermal energy, that it is almost inexhaustible source of energy. However, the major challenge is to access these temperatures. As you can see in the central picture, the temperature you reach is dependent on the temperature gradient, which is usually around 15 or 30 centigrades per kilometer, and access to this energy leads through drilling. In some territories with geological anomalies, you need to drill only up to 2 or 3 kilometers to reach sufficient temperatures for district heating or even electricity production. Unfortunately, this is probably only on approximately 3% of the world's territory, and in the rest of the world, the situation is that you need to go usually deeper, somewhere to 5 or 8 or somewhere even deeper what concerns the kilometers. Next slide, please. And this is also a case of, one slide back, please. With those maps. Yes, thank you. And this is also a case of Helsinki. In 5 kilometers on the left-hand side, you can see that subsurface temperature is around 75 centigrades. However, in 10 kilometers on the right-hand side, this subsurface temperature is 150 centigrades. So if we are able to economically efficiently drill to at least 7 or 8 kilometers, we would be able to get temperatures sufficient for district heating. This is also a case of a demonstration project of ST1 company in Espoo in 6 kilometers depth. We as a company endorse this effort, as this might be a really good showcase project. However, it is questionable whether it is possible to create economically feasible geothermal project in such depth using conventional drilling technology. Next slide, please. One slide back. Yes, this one, thank you. The reason is that the cost of conventional drilling increases exponentially with depth. This is caused by more challenging environment in deeper depth, causing tripping, non-productive time, change of drilling bits, and so on. Therefore, conventional technology is usually applicable up to around 5 kilometers, and beyond it is economically unfeasible. Therefore, geo-drilling came with a breakthrough technology which should eliminate this exponential cost increase. Next slide, please. Since it is a complex task, we have a robust 120 members team based in Slovakia with front offices in the UK, US, and UAE. We do have a patent portfolio covering the company's unique inventions on plasma bit drilling technology. Next slide. So plasma bit is the technology which is going to replace conventional rotary drilling, and it uses thermal impact on the rock, which disintegrates it. However, this innovation is not only about the drilling head itself, but also about the data management, driving the drilling head, also connectivity and control of the tool. This plasma disintegration method is designed to bring a significant advantage, mainly in hard rocks, where rotary drilling struggles the most. This might be advantageous mainly for Helsinki, where basement is composed mainly of granite, one of the hardest rock globally. Next slide, please. As a consequence, plasma bit should bring a competitive price also in the region beyond 5 kilometers and enable cost-efficient execution of deep geothermal projects, as shown with the orange line. Next slide, please. Where we stand now with the technology. Honestly, we are finalizing technology development, and now we want to start focusing on deployment readiness and commercialization. So the technology is not ready yet. However, we do have a clear roadmap indicating pilot drilling projects somewhere around 2024, which we see as a good fit with the timeline of Helsinki decarbonization plan. Next slide, please. Okay, so to sum up, we see deep geothermal energy project as a proper alternative for district heating in Helsinki. It's renewable, it's available anytime, and can also be anywhere for a competitive cost. We believe that geothermal energy should be an essential part of Helsinki district heating system. And honestly, it would be probably difficult to reach 100% decarbonization without geothermal energy. Therefore, we are ready to join existing consortium or team which counts with the use of geothermal energy in their intention or application. Or, on the other hand, we can alternatively lead this team or consortium if it is supported by partners having complementary energy technologies. For example, our idea is to use geothermal as a baseload energy during the whole year, and support it during colder periods by the use of heat from data centers or heat pumps from seawater and so on. However, we do not exclude any other technologies. We are ready, or we would be very happy to discuss the potential implementation of geothermal energy with some other alternatives. Okay, the next slide, please. So this is the last one. So if this is of your interest, you can approach me either through Helsinki Energy Challenge Partner Search, where I do have a profile, or through LinkedIn or via our company's public contact details. Thank you for your attention, and I very much appreciate this competition, which would hopefully serve as a showcase also to other cities and towns. All the best.
Okay, thank you for all the prospects, the ones who are willing to make an application and looking for other partnerships. I think we have got a couple of really good ideas here, which could even between themselves form some consortiums along the way. We were supposed to have a Q&A, but we've run out of time. I'm sad to say that. Please continue the questions about partnering with everyone else on the platform, which is here. www.hec.solved.fi, and more information about the competition is on the Energy Challenge website, and also you can submit questions which the Helsinki City will answer later on. And I still think I have to give the word, sorry about that, but I'm more than happy to give the last word to Laura. Please, Laura, can you sum up the event and also give your last word for the willing participants?
Yeah, just wanted to very briefly thank everybody for joining this and being part of this challenge. And of course, especially thank you for our panelists. Great that you shared the view, especially thank you for Marcus, who woke up very early this morning. I believe it was 6 o'clock or something similar. And thank you for all the participants. I'm sure you all have great ideas, and even if you disagree on each other's ideas, I think there was a really good comment in the panel discussion, and then you can perhaps challenge each other's when you come together. So instead of criticizing each other's ideas, it's good to brainstorm them further with people with different backgrounds. Then you can come up with something extraordinary. We are really hoping to see your ideas in our competition. I'm really sure that together with you guys, together with the partners who are supporting this challenge, we will be able to make a difference in the fight against global warming. Thank you.
Thank you, Laura, and thank you from my side as well to all the participants. It's time to log out. Thank you very much.